Next question is that, will this really help me to find the expected, rather the variance of y? Will this really help me?
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
Can we express the variance of y in terms of the conditional distributions of y given x and x? Interestingly enough, we can do. And that is one of my favorite principles in the entire statistics. It's called the smoothing property. In Blitzstein, it's written the Adam and Eve method. What is that Adam and Eve method? It is essentially trying to connect the conditional distribution to the marginal distribution step by step fashion. What does it say? You know this famous result probably, that expectation of y is nothing but, if y is, you understand that it's a joint distribution, right? So x is very minutely dependent and integrated with y. So we have to separate it out, and the way of separating it out is nothing but conditioning on x, right? So how do you do that? You do expectation of y given x. Now when you fix x, this is nothing but a function of x, right? So you again take the expectation. This time it's respect to x, and here in this time it's respect to y. So just remember this order. Okay, it's very important. Can you do it the same for y variance? Yes, you can do. And this is called variance of expectation of y given x plus expectation of variance of y given x. This is pretty beautiful, because here you just need to know the y given x distribution. Here you just need to know the y given x distribution. And since this is a function of x, and this is a function of x, you just need to know the distribution of x, which we already know. We know that y given x is equal to small x follows binomial x comma half, and x follows geometric half. Just number of trials. I'm writing it over and over again so that you don't forget that. Let's calculate this expectation of y given x now. The expectation of y given x will be nothing but x by 2, n into p, right? X by 2, right? X is a random variable. Now that's the whole idea. Variance of y given x. The variance of y given x is nothing but np into 1 minus p. So x by 4, right? Np into 1 minus p. P is half, 1 minus p is half, so it's x by 4. Now you have to take the variance, the expectation on this. So therefore, expectation of taking the expectation on this, you will get nothing but expectation of x by 4. And here taking the variance of this, it's nothing but variance of x divided by 4. Here it's expectation of x divided by 4. You see how beautifully it translates back to the original thing. So now you have to find the variance of x and expectation of x, where x is the geometric number of trials. And if you remember that for the number of trials, it's nothing but 1 by p. So here this expectation is p is half, so this will be 2. And for variance, you can calculate that. I forgot the result. You can calculate that, and you can also get it to be 2, right? Probably it was like 1 minus p by p square, or similar in this, or p square, 1 minus p by p square, something in this range. So 1 minus p will be half, and p square will be half square. So it will be 2, right? So for the number of trials, you get this. Yes, q by p square. So yes, so 1 minus p by p square, so you get 2. And adding this up, you get 1 by 2, which is half. So which is half plus half, which is 1. And therefore you can see the variance is 1. Right? Beautiful it is, right? Did you enjoy this problem? You can give a reaction. Did you like this idea of probability projection method? This is absolutely insightful. How you can use this. The basic idea is the following. You have to look through the problem and connect it to things, basic, simple, fundamental things that you know. That's all. But will we stop here? The answer is no. Why? The next natural question is that, can we use this probability projection method to directly find? So what we have done here, if you observe it very carefully, we have done this and we have found out by inspection as this. Now, can we find out by inspection the other way around? Because you can condition in two different ways, right? So y given x times x given y. And can we do it in this way and not this way? If we do it this way, it's a longer method, right? Because you're actually finding the distribution. But let's say if you find the distribution of y to be, let's say, something known, let's say binomial, let's say, for example, then you can directly write down the variance directly, right? Because you probably know the formula of the binomial. That's why it's helpful, right? If you connect it to known things, you do not have to calculate all these middle things. So if you can creatively, devise this whole thing into two halves, probably there is a better way out. Yeah, and yes, I have solved this. I will be posting this on LinkedIn after a few days. So I will share it to you. Please look into that. But it turns out that this is not easy to do in this case. Okay. It turns out that the condition is very hard. It turns out to be a mixed distribution. Why it turns out to be a mixed distribution? Not a general distribution like a known distribution. Yes, a mixed distribution of a geometric and a mixed distribution of a geometric and a constant random variable. That's a mixed distribution of that. And that's why it's hard to find out. And you can actually not find out easily. But I will give you a challenge problem. This is a challenge problem. Can you really find out that mixed distribution? This is a food for thought problem. Can you use this probability protection method to find out that distribution of y and connect it to this? For a small hint, I will tell you that the x distribution, rather the x given y, will follow similar something to geometric. Okay, the x given y will follow similar something geometric, and x given y is which is greater than 0, it will follow negative binomial. So it's a bifurcated aspect. And how do you know that it is something like this? It's from the following thing. Let me show it to you how it's actually happening. So, and then you can really complete the rest of the part. So it's like this, right? X choose y, 1 by 4 whole to the power x. Remember that here you're wanting given y. That means y should be constant, right? Y should be constant. So you cannot fix this x. So you have to differentiate out y. So what we can do is the following. So you have to differentiate out y and you have to keep constant x. Now, where is that distribution where the constant is fixed? So let's try to do this first one. Let's try to do for x is equal to x and y is equal to 0. When you have a complex problem, you do it for an easy problem. Just do it for y is equal to 0. For y is equal to 0, it turns out x choose 0, which is 1. It's 1 by 4 whole to the power x. Can you now distribute it into two halves? Yes, it's very easy because you know what this looks like. This looks like a geometric. So you can, but remember x is starting from greater than or equal to 1. Remember that. That is where x is starting from. So how can you write it? 1 by 4 whole to the power x. Does this make sense? It's 1 minus p whole to the power p to the power x minus 1, right? This is the distribution. So you want this. So if p is 1 by 4, there should be a 3 by 4 multiplied previously. And you can write this as this times 1 by 3. If you observe it very carefully, the 3 cancels and the 1 by 4 turns out to be 1 by 4 whole to the power x. So for this case, you can understand that x given y is equal to 0 follows geometric 3 by 4 because this is, sorry, I did it wrong. This will be p into 1 minus p whole to the power x. Okay, so geometric 3 by 4 times 1 by 3. That means probability y is equal to 0 is 1 by 3. When you do it for y greater than 1, let's say if you do it for y is equal to 1, that is where it turns out to be hard because it's x choose 1 now. So it's x into 1 by 4 whole to the power x. And that's where you can find out that you can relate it to something called negative binomial because the choose is there. So that's a homework for you. That's a food for thought problem for you. And I would love to see your solution. Send it to me personally if you want to. When this is uploaded to YouTube, please write it in the comment section and upload your solution there. You can upload it to a Google Drive of yours and give the link in the description so that anyone can see it And I would really get in touch with you to celebrate your understanding. And really, I would really like you to get in touch with you. And if your solution is really good, then we can arrange some awards for you. Okay. So all the best, and I will see the solution soon in the comment section or personally to me with proper explanations. So this is a food for thought problem, and all the best. Please solve this problem. I will see you in the next problem again. Okay, so did you like this problems? Did you like the idea of probability prediction strategy and how you can really manage it? Any questions out there? Any doubts? Please feel free to ask it in the comment section.
To book a trial class for your preparation courses of IITGM MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So in the first problem, we have discussed about the matrix multiplication relationship with the rows and the vectors of the matrices, rows and columns. And the second problem, we have discussed about this probability projection strategy, where we are projecting this complex distribution into a known problem, and how beautifully you can use the strategy to divide a joint distribution into a conditional and a marginal distribution without doing summation. Because to understand, to do this, find this marginal, you actually have to do the summation, right? And that's the best part about it. That's why this strategy is really helpful. And this is really beautiful. This is how our minds work. So this is all about it, guys. So thank you for joining today. If you have any doubts, please feel free to use our WhatsApp group. Okay. If you do not find our WhatsApp group, please feel free to let me know in the comments. We can give you the WhatsApp group so that you can discuss with our students.